Last year, you may remember the excitement when NASA successfully landed its Perseverance rover on Mars. Everyone in the room had to be suited up because they couldn't risk any contamination to the spacecraft heading to Mars in 4 years. Although Mars has long captivated people, fresh findings are challenging our preconceived notions about it. What if the red planet has a secret past gradually being revealed by modern technology? Imagine discovering proof that life once existed on Mars, or that there may still be unsolved mysteries there. Not only are we examining rocks this time, but we are also discussing organic molecules, odd green patches, and the finding of a subterranean ocean that has the potential to fundamentally alter our understanding of our nearest neighbor. Since Mars is one of the few planets where scientists can directly detect organic matter in water, two essential components of life, it has long been a target for scientific investigation. NASA's Curiosity and Perseverance rovers are among the missions that have found evidence that Mars may have once been habitable, but these are only the first indications. A huge subterranean water reservoir beneath the surface of Mars has been discovered by the InSight lander, one of the most recent and unexpected discoveries. In addition to casting doubt on our knowledge of Mars's past, this water may help future human expeditions. Imagine that beneath Mars's seemingly arid surface lies a massive ocean that may hold the key to the planet's capacity to support life. The history of Mars reveals a distinct picture. In the past, Mars had a thick atmosphere and a far warmer climate, which would have even permitted liquid water to flow on its surface. But early in its history, Mars lost its magnetic field, making it susceptible to solar winds. As a result of these winds, Mars's atmosphere progressively disappeared, drastically altering its climate and transforming it from a potentially habitable planet into the chilly, dry one it is today. The finding of this subterranean water reservoir creates fresh opportunities to investigate if Mars could have formerly sustained life and possibly could host life today, concealed far beneath its surface. In Jezero Crater, NASA's Perseverance rover recently found leopard spots, a pattern rich in iron and phosphate, elements essential to Earth's life processes. Since these substances are frequently connected to aquatic microbial life, it is possible that Mars once had comparable microbial life. The existence of these components raises the possibility that biological processes were at play, even though we cannot verify this. Likely formed by liquid water, Jezero Crater was once a river delta, a habitat where life could have existed billions of years ago. Organic molecules have also been found by Perseverance's Sherlock sensor, adding credence to the notion that Mars possessed the conditions required for life. The evidence for a once habitable Mars is further strengthened by the finding of calcium sulfate in the rocks, which suggests that water once passed through this area. Could the leopard markings indicate a distinct type of Martian life demonstrating biological processes different from those of earthly life? These results raise further questions about the possibility of extant and past life on Mars. More than just a chemical discovery, Curiosity's detection of pure sulfur on Mars provides insight into the planet's geological past and the possibility of previous volcanic activity. Mars's sulfur raises the prospect of subterranean volcanic areas that might have shaped the planet's temperature and produced habitats conducive to the survival of life. Understanding the circumstances that might sustain life on Mars is crucial for upcoming human missions and colonization. Mars may have been more livable than we previously believed if it had once had volcanic activity or subterranean water, providing clues about how to support viable life on other worlds. Understanding whether Mars may support life or offer resources could significantly impact interplanetary travel and future human residence on the planet, changing the way we think about space travel. As space exploration advances, the InSight lander's discovery of a subsurface ocean on Mars has significant ramifications for future missions. Our knowledge of Mars's past and its capacity to host life could be drastically altered if this discovery is investigated further. Future human missions may depend heavily on Mars's deep water deposits to supply water for astronauts and open up new technologies for sustainable life on other worlds. Neglecting this finding would mean passing up a vital chance to learn more about Mars's potential to support life, either extant or past. For billions of years, microbiological life may have been concealed beneath the ocean's surface. Insights on how life might exist in other hostile habitats, such as Earth's deep oceans or moons like Europa, could result from better understanding this environment. The danger is clear. If we don't conduct more research, we may lose the opportunity to find answers to important questions about the origins of life and the possibility of life elsewhere in the cosmos. The subterranean ocean on Mars may also be crucial to future human settlement, as our missions could encounter insurmountable obstacles in its absence. In addition to scientific advancement, the future of human space travel is also at risk. With the most recent data from missions like Perseverance and Insight, we are left with more questions than answers, as Mars continues to astound scientists with its mysterious findings. The hidden structures beneath Mars's surface, discovered through seismic data from the InSight lander, are among the most fascinating aspects of the planet's research. These enigmatic signals raise the possibility that Mars contains deep geological formations that are yet unclear to us. Could these formations be evidence of a subterranean network originally formed by flowing water, or perhaps the remains of old volcanic activity? Unusual seismic activity suggests there may be more than just typical geological forms beneath the surface. Even while NASA has released important discoveries, it's likely that more profound, undiscovered facts lie beneath Mars's dusty exterior, secrets that could fundamentally alter our understanding of the planet's history and its capacity to host life. There is growing speculation about secret Martian life. A strong hypothesis is raised by Mars's subterranean water and the odd seismic signals. Are there microorganisms or possibly more complex species concealed in these deep Martian reservoirs? Researchers hypothesize that these deep regions would have served as a haven for life if Mars had previously had warmer, more humid weather. We may discover proof that Mars isn't as dead as previously believed as future expeditions continue to investigate these hidden secrets. On the other hand, there is a considerable chance of missing a key finding. We run the risk of losing important information about the origins of life on Mars and in the wider universe if we don't continue exploring these subterranean formations and water supplies. It's possible that Mars is a time capsule that holds solutions to questions we haven't yet considered. The stakes are incredibly high. Deciphering the signals and their potential implications for future human exploration and the search for life is the true challenge. As we deploy increasingly sophisticated equipment and rovers to deeper regions, what might be concealed beneath Mars? The information we currently possess suggests something far more intricate than a desolate planet. Future research is made even more exciting by the prospect of subterranean waters, volcanic activity, and possibly buried microbial life. By providing insights into how life might survive on other planets, or how we might maintain life in interplanetary colonies, these findings have the potential to completely transform our understanding of not only Mars, but also life's existence in harsh conditions. We might learn the truth about these enigmatic formations in the upcoming years as technology develops, and we deploy more specialized probes to examine Mars's deepest layers. What we discover might provide crucial clues for human space travel and possibly offer an answer to one of humanity's most pressing questions. Are we really alone in the universe? The following steps are crucial and bold as we look to the future of Mars exploration. The Mars Sample Return mission may hold the secret to discovering Mars's history in a way that has never been possible before. However, there are still a lot of unknowns. Despite the prospect of bringing Martian rocks and dirt back to Earth, what will we discover exactly? Could these samples provide new information about the planet's depleted water supplies or show signs of ancient life? The stakes are only going to get higher as we keep pushing the boundaries of our technology. However, the difficulties extend well beyond sample collection. We will require technologies that can support life in the hostile environment of Mars as we work toward human settlement. The first step is the MOXIE experiment, which produces oxygen from the Martian atmosphere. What if it turns out to be considerably harder than anticipated to create a sustainable environment on Mars? We may not be able to overcome the challenges the planet presents with the solutions we are developing today, raising concerns about our long-term survival on Mars. Furthermore, it doesn't end there. With increasingly sophisticated robots that can perform tasks we don't fully understand today, future missions will push us beyond Perseverance. Envision autonomous laboratories on Mars that will gather compounds from the soil and provide real-time information to uncover even more mysteries about the planet. Can we rely on these machines to provide us with answers? What would happen if the technology didn't work? The pressure increases as these missions approach. Both the dangers and the discoveries have the potential to be revolutionary. Will we actually solve the riddles of Mars, or will we be left with even more questions? The journey to Mars might not be as simple as we had hoped, and critical decisions still need to be made. Exploring Mars and the prospect of making it habitable in the future provide enormous and fascinating challenges. We face several significant challenges as we investigate Mars's potential for life, challenges that could change the course of exploration and technology. Understanding how to make Mars habitable for humans is one of the main challenges. Although scientists know that liquid water may have once existed on Mars, human settlement is severely hampered by its hostile climate. The surface is exposed to harmful solar radiation due to the thin atmosphere and absence of a magnetic field. Human existence on Mars might remain a pipe dream in the absence of cutting-edge technologies like radiation shielding and sustainable oxygen production. However, addressing these challenges might result in new developments in space architecture and advances in material science, which could also impact how we live on Earth. The terraforming of Mars is another urgent problem. The concept of turning Mars back into something more like Earth is intriguing if the planet originally had a more pleasant environment. However, terraforming is a huge task due to the absence of a global magnetic field and the challenge of reinstalling an atmosphere that can support liquid water. Overcoming this obstacle may result in advancements in climate control and planetary engineering technology that could be used for purposes far beyond Mars, such as halting climate change on Earth. The odd green patches that the Perseverance rover found are even more enigmatic. These abnormalities might indicate a distinct Martian ecology or microbial life. We're still working on the mystery of what these locations actually mean. What if they reveal something wholly unanticipated? In addition to transforming our knowledge of life on Mars, the discovery of these biological hints may spur cooperation between astrobiologists, planetary scientists, and perhaps the biotech sector. The discovery of new ecosystems or living forms may lead to the development of completely new biological research areas. Despite their seeming difficulty, each of these problems has the potential to lead to important technical breakthroughs. Innovative solutions, like self-sustaining homes, groundbreaking energy systems, and improvements in space travel technologies, could result from the challenges we face. To overcome these obstacles, cooperation between countries and industries will be essential. By bringing together the skills of scientists, engineers, and space agencies, we can push the limits of our knowledge and make Mars colonization a reality, ultimately opening up new horizons for humanity. Although the journey to Mars will not be simple, there are countless opportunities for creativity. As with any significant task, the rewards of the risks we take now could be far greater than we can currently imagine. Though there are still many unanswered questions, Mars has provided intriguing hints about its past, including the possibility of microbial life in subterranean waters. What if life once existed on Mars, and it was a thriving planet? What will we discover when we delve further into Mars's past? As we prepare for upcoming missions, our understanding of the planet and our future beyond it may change as a result of the answers. There are still mysteries on Mars, and the search for them is only getting started. What lies beneath, and what will we find out next?